So, hello everyone once again. My name is Marcin Górski. Let me introduce myself a little bit. Mm, I'm working since 2010, so it's over 6 years as a aviation forecaster. So my briefing will have some aviation forecast attitude. I hope that it's fine for you, and I hope it will be suitable for you and maybe even helpful in some of your everyday duty. I have seen previous briefings. It will be a little bit different because I will concentrate on this, on what we in aviation, weather in aviation forecast are concentrate on, especially that our current situation over Europe is pretty stationary. So I think it won't be bad for that time. So So where are we at the moment? I'm speaking from Poland, from Warsaw. You can see it where exactly the boundaries and everything is. Uh, I'm speaking from Warsaw, from capital, and in Warsaw, in capital, we have our main office, and the building and the whole institute, meteorological institute, is in Warsaw. 30 of you is already out there, so I guess they know what I'm talking about. Uh, and as you can see, we are living in the temperate climate zone, as you know, which you call intermediate. So what does it mean for us that we have influences of continental and marine climate? So we have a lot of fun, especially from aviation point of view. Which I would prefer it would be most stable or something like this, but unfortunately it doesn't happen. So our area is having a lot of influences from south, from north, from marine, from continental weather. So so here, as probably as most of the Europe, we can have all kind of phenomena which are given, except let's say this really severe ones like tornadoes or something. But everything with fogs, with rains, and with frontal systems, we everything have here. And today we had beautiful situations over Europe, beautiful for probably for most of the people, but from the aviation point of view, it wasn't so easy for everyone. I will show it. So our our office, my main office, few words about our institute. Main office is in Warsaw, which you can hear here. We also have two main offices in Wrocław and in Krakow. And from these cities, we are giving forecast for aviation users through all for all area of our country. Um, Here is our main building, Institute of Meteorology and Water Management. 30 of you are already there. I guess you are somewhere over here. So I'm that's right. I am pointing from home, from Warsaw, from the north, from south side of the city. Here is our office. Here we have a lot of departments which are included in our institute. Most of them are kind of general, weather offices, water management offices. Our office is somewhere over here, and it's doing all products for aviation users. Next, what I have to tell you is that we have specific attitude to the weather. Most of you, when we are during our duty, doing our products, we are concentrating on everything, on temperatures, on weather phenomena of all kinds, on precipitations. but for aviation forecaster, there is only part of it which is really important for us, and we are going to much detail in some of the elements of the meteorological elements, but some of that we just don't care, because this is not what aviation users, what aeroplanes their needs are. So that's why I will have this kind of attitude in that presentation. I hope it will be okay for you. Here is our website of my department. It's www.aviacja.emgw.pl. You can you can see here our country is divided by the sectors, aviation sectors. We are over here in Warsaw. Also, all of these points are airports on the area of our country. Some of them are official, some of them are just only for the sport, for aviation sport reasons. Some of them are not civil. Uh, uh, the purpose is to serve during the, let's say, military basis. So I have main question to you all. Is there anyone who is aviation forecaster in that group? Carolina, Lana. Okay, Irina, Tatiana. Okay, so there is a lot of you knows what I'm talking about. That's great. That's great. So tell me, please, if I would show you something like this. Well, first of all, please tell me where are you from? If you could point out on the map your place and you're working. Okay, we have Deutschland, we have Italia. That's great. I guess that for the people in in institute building cannot show here Latvia. Okay, I guess that if we would divide those all stars from the Europe, we will have our map full. But now we are all pretty much in the center of Europe. Okay, could you tell me now, please, uh, uh, so aviation forecasters, where I'm from? From Lithuania. Okay, so the aviation forecasters are mainly from this side of Europe, so from Baltic republics, let's say, in general. Okay, that's fine. Especially that today, as you probably may notice, we have a lot of fun with low clouds in that area. Okay, great. So let's go to concrete. So if I will show you something like this, will you know what I'm talking about? This is the two kind of information which is given by aviation forecaster. It's kind of observations. It's coded into meter code, and we have two, well, let's say basic products that we are making is the observation called meter. This is the airport which it is for, and also we have the forecasts for accurate airport. If please tell me no if someone doesn't know what it's all about, so I will give you a few sentences about it. Okay, I can see that everyone is pretty more comfortable with that. Well, why I'm showing this is that because I will concentrate on the two main things, which are probably the most important thing for all pilots, which is the visibilities, which you also have somewhere over here in meta code, and clouds and ceiling. So how high is the base of the cloud above the ground level? These are if it's low cloud, because the pilots have to have some 1,500 space between the surface and between the ceiling of the cloud, so they can do the operational work. And this is the most important thing for us to forecast, right? And from this attitude, I will give you some words about the situation over Europe at the moment. Here is one of our basic products. For Poland is called SWC, Significant Weather Chart Map. We do not show their temperatures or something like this. There is a few elements like visibilities for all two areas, and the clouds with the ceiling, the bottom one and the upper one. Also, there are some features like icing and turbulence zones, which can be affected. This is the map from yesterday's from our operational work. It looks like that, and this is what we are concentrating on. This is one of our products. This is the product. This is the map from yesterday, 18 UTC, and this is how it looks in general. What we are concentrating on. So let's go to our situation over Europe. Well, in my operational work, at first look, I like to have a look on the RGB air mass image. It's because everything is in there. Mostly, what I need to know at the first look, air mass over our continent, over our country, and which one is the moist one, which air mass is the dry one. So, and where are the frontal zones when I can expect something will happen. From my point of view, I prefer when there are some fronts and going through. So because this is the simple to forecast weather, but if there is a kind of not dynamical movement over my country, I know that situation won't be easy as I would prefer it would be. So yesterday at 12 UTC, the situation over Europe was, as you may probably see, we have three main air masses over Europe. You can read it from this image. The basic two ones was the on the North Atlantic Sea was the really cold one. You can, as you probably know, distinguish the cold air masses with this blue, purplish colors, and a little bit warmer air mass over the whole Europe. Frontal zone, main frontal zone, which is dividing these two air masses, and what is really important for all of us, that we can see some cloud structures, probably as we may think at the moment, connected with the low over here. But if you will compare this side of the image with this side of the image, you will see that this one is more greener. It's kind of it's drier for sure, but you will see that this here we have this air mass is divided between all those. Excuse me, but anyway, we can see that this part of Europe is more moist one. We have the clouds over there, and especially the low clouds. And here is the second different part of this air mass. So I know basically what I can expect going through the next analyze. Now, if we will put on the infrared image the 500 hectopascals temperature, we will have a closer look on why it is distinguished like that. So in this airmass, well, we can see this frontal system, and as we can follow the isotherms on the level of 500, we have warm sector here, and behind it there's a cold mass, and this all red, uh, and this all air mass here we have warm air mass. On the 500 hectopascals map, we have warm advection, well, not advection, but warm mass over here, and the intrusion of the colder air over southern part, central south part of the Europe. So here we have some basic knowledge about what is going on over Europe. If we will have a look on the geopotential height on the 500 hectopascals, I always like to do it from that side, so I will go from upper layers of the atmosphere and going down. So anyway, here we have, I would say, the three main areas. At the moment, we have the high over Norwegian Sea, and a big part of Europe is under the influence of that one. We have beautiful ridge with the axis here and axis here. In this warm, as we have seen, in this warm air mass. Second is the low over France, somewhere over here, and in this cold air mass, which we can see it all as well on the relative topography map. It is in this main intrusion of a little bit colder air than it is on the north side of this. As you may see, we have one more interesting thing. We have the call here, right? We have two lows, two highs, and here there is a call which we really do not, well, I would say, appreciate in our operational work, because everything what is the worst is already there. So there are fogs, low stratus clouds, but this is the only 500 geopotential map, so we will have a look on how does it look on the surface. Here on that map, you can see that the center on 5 hectopascal map is here, and when the surface on the surface isobar is somewhere over here, so it's not in the same place, which can give us some information that that system is starting to dissipate. It's cyclicalized, so it's tend to weakening. So when I hear that cyclone or front is dissipating, I know that this is the worst weather what can be, because it's getting older and older. It's getting fulfilled, so it's really moist, and everything can be out there. Also, what we can see here is the ridge of high pressure. Surface ridge is over here, and just behind that we have this red. We have here the warmer air mass. So when I have the high and the ridge is dividing two air masses, colder and warmer one, I know that there will be a weather where I can expect something can happen. If I will go through, this is the map of advection at 500 hectopascals, and there are two things what are making me worried. First of all, on that frontal probably system over here, when we see a lot of cloudiness, when there is an advection, especially warm advection, included into that area of cloudiness, as we may see here, I know that this is a kind of stationary weakening front, probably old occlusion, old front dissipating, and this is the bad weather for me. Probably I will see that. And the second what I can hear, that this frontal system, we do not have any advection over here, because this high which was on the Norwegian Sea is blocking that one. So from that point of view, we can see what we can expect today. So mainly this whole system will not affect us in the next days, but all these air mass between this height and this low will have an effect on our days. The surface maps, these are the surface pressure synoptic charts from Metaphys from London. Our situation is pretty, let's say, easy and simple, but it's not as simple as we would like to be, because the main system in this is this high over Norwegian Sea. But here we have this what I was talking about, and what I wanted to show you with this occlusion and this weakening fronts here. And the second of this is here weakening warm front, which is associated with this whole warm mass in that reach. And this is the two main problems which will be making the forecast pretty intense and pretty I would say dynamic and hard. This is the movement. We can see this is 6 UTC of yesterday. This is 12 UTC. So they are pretty stationary almost. The only movement which we can see is this cold front going northwest. And here is something straight from the battlefield. I don't know if you are. I'm wondering if you are drawing this kind of stuff in your offices. This is the handmade drawn map of surface pressure with front system. Can you hear anything? Can you see anything of that map? Can you see the isobars and the main systems like lows and highs? Okay, great. I can hear that you can see it. Could you tell me, please? Do you think? Are you doing this in your office in normal time, normal duty? Because I'm wondering, because for a lot of people would say that and thinks that this is not really necessary thing to do, but for us as we are aware that we can have in half of a second map like this, but when we are drawing this, we have uh, a lot of things that is giving our very safe and certain informations about the curvation of the isobars, which is really important. We have synoptic stations informations when we have accurate ceilings, accurate visibilities over whole Europe. So when we are on duty and starting this, we are drawing map like this, and we are trying to make this all analyzed with front systems and all ridges and the most dangerous areas to have been seen on that kind of map. So this is the map from yesterday, from 6, and we have seen that this whole all things like fogs and low clouds were here. I don't know. Probably you cannot see it. So I have point out this for you. So there are two sectors two areas where we have a dangerous phenomena like fogs and low clouds. One is connected with this rich and warm air mass advection over here, and the second is this whole old occlusion which is weakening over central South Europe. And here we have drizzles, we had fogs, we have low stratus clouds. now I will show you the RGB multispectral compositions. I don't know if you are aware how it's made. I will just concentrate on that what we are using mainly. That one is this is the general thing about RGB images. So we all can have clearness about how it's done. It's done like the three colors red, green, and blue are allocated and are given to one of the three channels. And these are the channels or the channels difference, and one is put it for red. The second channel is put it for green, and the first channel is put it to blue. Of course, when I'm saying channels, I mean wavelength in the radiation. In the radiation of Earth, it depends if it's visible, if it's infrared, and when we will have this whole red, green, and blue connected with all channels, we can expect that we will have some elements which are the result as a which will result as a different colors. And thinking about what we are trying to have on the image, we can take we can take the advantages of that channel and put it as we want to put it, and do not pay attention to all the stuff that we don't want to pay attention. So here we will, in my operational work, the most important things are the microphysics images. These are the 24 hours microphysics image, day microphysics image, and the night microphysics image. Especially when we are working, there is always the difference between the night and day, and we have some problems with distinction of the clouds and fogs during the day and during the night. But these products are giving a very helpful and nice overview what we can see and even what we can forecast on the 1 hour basis. So we are using 3 different microphysics satellite images. 24 hour, which is really basic distinction. If you will have a look on the channels that they are included, they're only infrared channels, so this is why it's 24-hour microphysics image, because you will have it through all day and night. And day microphysics, it's called day microphysics, and it's not useful during the night, but it's very useful during the day. It has visibility channel, so this is why it's so important to not use that do not use that image during the night, because you will not see everything what you want to see. And the night microphysics, which has in it two different let's say channels in one, put it in one channel, but they're the combination of the two ERs, and the third channel is ER as well. So during the night, this microphysics is the more accurate, and here you have for example, this is what RGB of night microphysics looks like. And this is the main product, the main color that is expected. So this is the kind of bright green, bright yellow kind of stuff. So this is the most important thing about in our work from the satellite point of view, which we are using. And so here we have the situation from yesterday, from 6 UTC. We can hear on the 24-hour microphysics that whole Europe is covered with that image what we are expected to have. And what is the most important for us are these low clouds. The low clouds, as you probably know, are the stratocumulus clouds, stratus clouds, and so on, and as well the cumulus clouds on the low base with the low ceiling. And what we can see from the 24-hour microphysics map is that yellowish green ochre colors are the most important for us. And so these will be the areas where we will have it in our photo in our satellite image at the moment. And as brighter as it goes, as lower it is. Unfortunately, when there's a stratocumulus over stratus cloud, we will see this top. We will see the top of the cloud, so we will see the stratocumulus cloud. But this gives us a really good information about what is going on, and we can see that yesterday we had this advection of warm air, which were when as a result of that in the lower troposphere was the low clouds going south. Here also we have beautiful thing, which is probably advection fog over marine over the sea. Here we have this let's say more darker colors of yellow and green, which are connected with this old occlusion over the Central Europe. But here is the main structures which we are looking for from our point of view. And now when we will go to night microphysics image, we will see no, there is a little bit mistake in the presentation. Anyway, do not pay attention to the channels used because they are wrong. Here, excuse me for that one. Anyway, when we will see the night microphysics, which is that one, we will see with really great distinction the areas of really low clouds. Here we have really bright green clouds, and below probably the stratocumulus cloud because it's a little bit darker here. So here is the place where we can expect the low clouds and the fog stuff will happen. And the second one is over here. So we will know we know where we can expect those all stories like fogs, drizzles, and stuff like that. Here on the day microphysics, when we can see the same thing, it's not a great distinction as it was, but if we will go into details, we'll probably be able to distinguish the greener and yellow parts of that clouds, so that we can see where we can expect those most interesting phenomena like low clouds. When we will have a look on the meteors from yesterday's from Estonia and from Slovakia, so it was from Tartu over here and for Bratislav over here. We will see how it looks in real from the ground level point of view. And we have seen that really low cloud, 300 feet cloud over Tartu, Estonia, 2 kilometers, 80 meters of visibilities. So probably the conditions, and here we have even lower base, 200 feet height. Which are probably the conditions that will result as unflyable conditions, and the aeroplanes will have a lot of problems, and with landing especially, and probably airport is closed, as probably if it has ILS system. But we can have a look how it looks from the ground level, what we are looking from the satellite image in Tartu, Estonia, and with this occlusion, which we are affected, Bratislava were affected by this. We can see how restricted we are when we are looking on that kind of image, because the clouds are also on the low point, because these are kind of 300 meters structure and a few structures below that, but not really important one. Over 10 kilometers visibilities. So under that occlusion, the conditions, flyable conditions, good as it can look at the first time. What I want to tell you is that do not really, if we want to distinguish this kind of things, the natural color RGB will not really give you a lot of information about it. It will give you information about low clouds, but if you want to go deeper in that and to see if this is a very low cloud or just low cloud, it won't give you that information. Perhaps, well, it has a great thing like here RGB image. That the resolution is really high because with the higher IRV image, high resolution image, this resolution is 1 kilometer. So you will have a lot of detailed information about the fog, radiation fog, if it's like this, but you will not have the information how low it is. So this is how does it look on the natural and HRV image. And here was the forecast for today. As we can see, the low on the center of Europe is here, but it's not connected. It's not associated with the surface low. So probably this is the dissipating system. Still, we have a really good and well organized high, which is still going on the Norwegian and North Sea, with the ridge just above Poland. So the situation is pretty stationary about it. But what is for me, what is really not good, and from my point of view, is that this low is dissipating that one, and everything what will be happening there over France, over Switzerland, over areas affected about it, with that one will have some dangerous weather problems from the basics of aviation forecast. Anyway, this is a temperature 850 degree 50 hectopascals temperature map. Still, the situation is as it was. So the main air masses are over here, colder and the warmer one. Here is the advection. So we have the advection at 850 hectopascals geopotential. Over Poland, we have advection of warm air, which will be affecting us, especially during the nighttime with low clouds and fogs. Also, here we have with that area, we have kind of advection, but it's here on the model is a little bit different because we have a lot of water influence, and so we cannot look it on the straight like that. But also we have few changes on that part. Here are the prognostic forecast maps for Europe for today from yesterday. So here is this dissipating warm front in the ridge, and totally invisible low which we had yesterday, but it's not already here. But here in this low gradient area, and the advection of warm air, we will have for sure low clouds on the north of our country for today. These were the forecasts from our office in the morning. So we had here what we were interested in were stratus clouds and the visibility, also the radiation fogs, because we had a low gradient area, cloudless, so radiational fog on our country. And this is how it was today at 6 o'clock. So nothing happened. Have changed about main situation on the air mass. Here we have 24-hour macrophysics image. So we can see that the low clouds are really getting more intense on the north of Poland and the Baltic Republics areas. Also, these occlusions and the frontal system connected with this middle layer low is dissipating. From when we will have a look on the dimicrophysics, as we can see day and night border, daylight boundary. We can see this really greenish points and areas where we for sure will have some fog and stratus. Here it is covered. It's a little bit pinky, so it's covered by stratocumulus. So we cannot be 100% sure that there is a stratus below, but from the previous knowledge and experience, we have seen that what is going out there. When we will put the mean sea and put it on the ER image, we can see that we cannot really see anything from the low clouds. You cannot distinguish really nicely the clouds over here. Maybe over here because they are a little bit better, sharpened and visible than it is here. But anyway, this is why the ER images are no. Okay, I have information that I need to be hurry. I'm just finishing my presentation, so don't worry. And this is the weather which we had today from Warsaw, from Poland, for example, at 7 UTC. When we will have a look on the Gdańsk, so it was on the area of the warm advection. We can see here the fog out there. Also, we had radiation fog over Krakow, which was over here. We do not have in our country airports in that area, but we had some information from Kaliningrad, which is the north from Poland. Over there we have 400 feet stratus clouds with 8-kilometer visibilities. From Lithuania, from Vilna, we had 300 feet stratus cloud. From Lithuania, we have also 200 feet. You can see that visibilities were pretty good. So which is typical for this elevation type hot weather, but this really low clouds which were making the conditions unflyable. When we will have a look on this frontal area and the observations from there, we have Vienna from Austria, and we had fogs out there. We have low stratus clouds, but in the western part of that frontal system in Toulouse, France, weather was great. There were no clouds, visibilities 8 kilometers and over that, so it was really nice. In the center of that high, which were making conditions were as well radiational fog in London, for example, which we can see over here. And that's all for me. Thank you. Sorry for getting you longer than it used to be. I hope you have something nice for you from that point of view. So thank you very much.